Okay, so we're doing a few things today. There's a couple of sort of definitions that you kind of want to know. And then in general, what we're learning how to do, though, is factor higher order polynomial functions. You know how to factor quadratics. Hopefully you're very good at that. We're going to get a little bit of practice. Beginning of the unit, remember I said there's some warm-up and you want to get good at it. Now's the time where that's going to help. So we're basically factoring, but there's these two theorems that we need to learn and have a solid understanding of as well. Remainder theorem and factor theorem. Okay? But take a look at our learning goal. I can factor polynomials. Like that's basically what we're learning how to do. In grade 10, you learn how to factor quadratics, right? Tricky trinomials, simple trinomials, and you do all difference of squares, all that good stuff. And now we're learning how to factor bigger things. Okay, so remainder theorem. Think about what this means for a minute. Remainder theorem says that if the function f at x is divided by x minus a, so that's like if you're dividing this function by x plus 1, right? That's what we were just doing, what we just took up in the learning goal, that good stuff. If you're dividing that way, the remainder, when you do the long division or synthetic and you get the remainder, turns out there's an easier way to find it. The remainder is the value of the function at that point. If you think about this, it makes a lot of sense. So what does that mean? It means I take the value of a, so in this case it's -1, in this case it's +2, and I evaluate the function at that point, and what I get would be the remainder, same as if I did the long division. Does that make sense? So on a test, I'll give you this heads up, you're going to be asked to find the remainder. How would you do that? This way, not by synthetic or long division. Like that would be, it's going to be a 2-mark question and you're going to do a page full of work to do that. And you're going to be given a space like this, right? So this is something that you need to know. We're going to use it in a specific way over and over and over again. And then some people forget, like in general, what remainder theorem is. Okay, so let's do an example here. So if x plus 1, determine the remainder of each divisor. If I'm dividing x plus 1 in here, then my a value, you don't have to write this out, but my a value would be -1, because it's x minus a, right? And so what I'm going to do is I'm going to find the value of f at -1. And so it's 2 times -1 to the 4th plus 5 times -1 to the 3rd minus 29 times -1 squared minus 38 times -1 plus 120. Try that. So when I do this stuff, I try to do as much in my head as possible. If you make mistakes doing it that way, then I guess use your calculator, but it does slow you down a little bit. So for example, when it's 1, it's really easy, right? So, but -1 to the 4th, that's going to give me positive, so this is 2. -1 cubed is going to give me negative, so -5. -1 squared is positive, so -29. And then plus 38, and then plus 120, right? And then I just add those on my calculator. 126? Is that right? So is x plus 1 a factor of f at x? It is not. That was an easy way to determine if it was a factor, wasn't it? I got a remainder that's not 0. Therefore, x plus 1 is not a factor of f at x. It's very important. Everybody happy with that? Okay, try the next one. What do we get for this one? Hope you got 0. Supposed to get 0. Therefore, x minus 2 is a factor. But that's not a part of remainder theorem. Remainder theorem is just the idea that if you take the divisor, what you're dividing by, so x minus 2, but you think about like the minus 2 actually means positive 2. If you evaluate the function at positive 2, the result of that is the remainder had you done the full division, right, of that division process. Any questions? Does that make sense? It's easy, but then people forget. Whenever you're asked to just find a remainder, this is what you would do. This is the easy way of doing it. Okay? So factor theorem is a special case where we realize that we already talked about this. If a remainder is 0, then you've got a factor. So if I evaluate f at x for some value a and get 0, I've found a factor of f at x. That's what factor theorem says. You don't necessarily need to know these by definition, although it's not a bad idea. Remainder theorem is something that you want to remember because we're going to use factor theorem a lot. But don't forget about remainder theorem as well. Okay? But factor theorem is the important one because what we're trying to do when we're factoring is find factors of that function. That's what we're trying to find. Right? Any questions about any of that? Okay, so look at what the instructions say. Factor each of the following fully. And I have a degree 4 polynomial with all kinds of stuff in it. Like you've probably actually factored a degree 4 polynomial before, but it would have been something like this, x to the 4 minus 16. Something like that, right? That just kind of works out nicely. But this one, we can't factor with any of the skills we have from grade 10 or grade 11. So this is new. So our first step in this process is to just find a factor. And the only way to find one is to start trying, randomly guessing, and trying different numbers using remainder theorem until we get 0. Does that make sense? So if I was to start this question fresh, what number would I start with? 1, because it's easy to work with. And often you're going to find we're pretty nice and we give you functions that you have to factor where one of the factors is 1, right? So you try 1 and you go through it. So 2 times 1 plus 5 times 1 minus 1, and you check. Oh, not a factor. Okay, try -1 because maybe that will work. Nope, not a factor. And then move on to 2, -2, 3, -3, 4, -4, 5, -5, 6, -6. If you're doing a test and you've gotten up to -6, you've done something wrong, you've gone too far. I wouldn't really be very likely to give you one that big. Okay? It's usually you could find it in a few tries. Everybody okay with this so far? Now, some of you might have noticed that this is the function we already looked at right here, I believe, right? 2x to the 4th, 5x cubed, 29x squared, 38x, and 120. It's the same one. So we already know that x minus 2 is a function, again, because f at 2 gave us 0. Therefore, this is how we would do this question, though. On my calculator, I would just try a bunch. There is a little trick that if you have a hard time doing it without writing it down on scrap paper, I can show you how to kind of keep track of the different ones you try. But what I'm going to do is I'm going to do f at 2 equals 0. Therefore, x minus 2 is, oh, geez. Okay, try that again. F at 2 equals 0. Therefore, x minus 2 is a factor. Does that make sense? So normally you would have to do a little bit, we'll do another example where you do this process, but normally you'd have to do a little bit of work to find that number 2. But once you have it, you make this little statement. And so then we get f at x equals, well, hold on. No, sorry. Now we need to do the division first. We don't know what it equals yet. So we're going to do the division, x minus 2. And what are we going to use for this? Synthetic division, because it's a lot easier. So 2, 5, negative 29, making sure that every term is there. So how do we do this again? Bring 2 down. Negative 2 times 2 is negative 4. Subtract. Negative 2 times 9 is negative 18. Subtract, which negative 29 plus 18, so that should be negative 11. And then 22. And subtract, and that gives me 60. Sorry, negative 60. Perfect. And so take a look at what happened here. Negative 2 times negative 60 gives me 120. Why was I expecting that to happen? Because it's a factor. We already know it's a factor. So if you did the synthetic division and didn't get 0, something's gone wrong. Either you made a mistake finding the factor or you made a mistake in your division. Good? Okay. So now we can go, therefore, f at x equals x minus 2, and then 2x cubed plus 9x squared minus 11x minus 60. Everybody okay? Plus 0. But our instruction said factor fully. Do you think we factored fully? I don't think so. So here's what we do. We let g at x equal 2x cubed plus 9x squared minus 11x minus 60. And we start looking for another factor. So go ahead and try that. Try some different values. We've already done 1, or we did negative 1. We haven't tried positive 1, so you could try positive 1. I think I found negative 3 works. Anybody else get that? Yeah, you got negative 3. So I tried negative 1 because we did positive 1 before. No, I tried positive 1 because we did negative 1 before. That didn't work. And we already did positive 2, so I tried negative 2. It didn't work. I tried 3. It didn't work. Negative 3 worked. So it is a bit of a process. Is there an easier way to tell what? No. In this case, no. There is a trick, and we'll talk about that either in the next example or tomorrow. But there is a trick sometimes that can help you narrow things down a little bit. But in general, no. You just have to kind of try things. Okay, but this turned out to be 0. Therefore, x plus 3 is a factor. And then what would we do? Repeat the process. I would, again, pick synthetic division. So, but now we're dividing g at x, right? So 2, 9, negative 11, negative 60. Nice. All right, therefore, I always like, whenever steps don't flow, so like, I had a bunch of things that were equal, but then I threw like synthetic division in there. It's not equal to the line above it, you know what I mean? It's a different process. That's when I always added therefore. Like, so what you're saying is what this tells me is the next line is true, right? Like I'm interpreting it. So therefore, f at x equals x minus 2 times x plus 3 times 2x squared plus 3x minus 20. Do you think we're done? Do you think that might be factorable? So how do you know if it's factorable? Does anybody remember how there's a quick way of telling how something's factorable? You might not have, I hope you learned this in grade 11. You might not have. Discriminant, b squared minus 4ac. This will be summarized, I think, in one of our next lessons. So there is a trick, but if I think of this as a quadratic, I check b squared minus 4ac to see if it's factorable, right? So you can use that, or you can just try it. I do think that this is factorable. And so hopefully you're good at factoring tricky trinomials. And the way I factor, everybody's got a little bit of a different way. If this is prime, I know it's 2x and x. And then I just pick factors of 20 and in my head start trying them. Okay? So this is like I would recommend that if you're not this fast at factoring, that you practice a little bit and get this fast. You shouldn't have to do a lot of work to factor even a tricky trinomial. Even if this wasn't prime, you still should just be able to do it in line. Like I'm looking at this and I'm thinking it's got to be 4 and 5, right? They add to 3. Don't you think it's probably like that would just be my gut to try 4 and 5? And I'm looking for a difference of 3. So indeed, 4 and 5. 2 times 4 is 8. So positive 8 minus 5. Got it. And now that's factored fully. Any questions? Nope, there'll probably be like 6 or something. It'll be a lot. Yeah. Yeah. Hey, you took this course. Nobody put a gun to your head. All right, let's try another one. And one of them is going to be degree 5. Maybe. We'll see. We'll see how I feel that day, if I'm in a good mood or a bad mood. I'm going to show you a shortcut in this example. And if you don't get it right away, you'll work towards it and get it. Some people get it, some people won't. So we used synthetic division twice there and didn't need to. We only needed to do it once. I'm going to show you a shortcut, but you can always just use synthetic division until you get down to the quadratic, right? Okay, so what do we do for this one? Oh, and I can show you a little shortcut for for looking for factors here as well. Okay? So how do we start a question? We start looking for a factor. So try 1, try -1. Here's the trick though. See how 27 is the last term? Your factors have to be factors of 27. And think about this. After you do a couple of these, at the end we'll look at it and we'll think about this. But once you're done the question, if you think about what a factor is, of course it has to be a factor of 27. That's a little bit more complicated than just this. We'll talk about this later. But in general, for now, that's very helpful. What does it tell us for this question? It means we don't have to try 2. 2 and -2 will not work for this question. And when I look at it, I see divisible by 3, divisible by 3, divisible by 3. I'm thinking 3 is going to work. Or -3, I don't know which one. Or maybe both, right? But try 1 first, because I think 1 or -1 works. Which one? -1 works. Because that would make that -32. No, -1, sorry. That would be -2. No, 2 minus 5 minus 15 plus 45 minus 27. So this is 0. Therefore, x plus 1 is a factor. So we have to do synthetic division here. I'm going to let you try this for practice. Yeah. Yeah. Yeah, there's going to be lots that work. Go back to this example. Where's the end? Like any of these would work. So positive 2, negative 3, negative 4. In fact, 5 over 2 would work, but who's going to try that, right? But we'll talk about that later. But yeah, like any of those factors you could have found in the first step. Why you would start with negative 4, I don't know, because one's easier. But so you typically will find the smaller ones first. And it's a little bit easier to divide with the smaller ones into the bigger things. It's kind of a nice way to do it, but it's exactly like that. Right. No matter what order you do it, you're going to get down to the same prime factors. If you're doing prime factorization with a number, that's what we're doing with this, prime factorization. So your order of writing them would be different, but you get the same values precisely. Okay, so let g at x equal this thing. 2x cubed plus 3x squared minus 18x minus 27. And what did you find worked? 3 or positive 3 or negative 3? Positive 3, so now we already have a new one. Therefore, x minus 3 is a factor. Now here's a shortcut. Everybody watch carefully. You might want to put your pencil down and watch. Therefore, f at x, we don't have to do synthetic division again. But you can in a pinch. Some of you will pick this up quickly. Some will find it harder. I'm going to try to go through it carefully with you. So normally I wouldn't write this down, but I will just for reference. So 2x cubed plus 3x squared minus 18x minus 27. X times whatever I get here is going to have to give me that. Right? That's what we're doing. We're dividing. So what does it have to be? 2x squared. Okay with that? 3 times whatever is in the last position there, negative 3, has to give me that. Is that true? Because those are the only two things that are going to multiply together to give me the constant. So this is going to be plus 9. So I just have to find the middle term. So this is a little bit of a tricky part, but just watch. Negative 3 times 2x squared is going to give me negative 6x squared. But I want 3x squared. So what do I add to 6x squared, negative 6x squared, to get 3x squared? 9x squared. What do I multiply x by to get me 9x squared? 9x. I'm going to go over that again. And we can check this. Okay? So to get this x squared term, I'm going to multiply those two and those two. Only. If you do the expansion, that's what ends up happening. So 9x squared minus 6x squared is 3x squared. But watch, I can check it. If I do negative 3 times 9x is negative 27x, plus 9x is negative 18x. They both work. And they'll both always work. It's not like one will work and the other won't. That can't happen. They'll both always work, but it's a check. So that may seem a little bizarre, and you might be a little bit unsure of that, but trust me, you want to get that. It's a lot quicker than doing synthetic division again. Once you get it and it clicks, it's not that bad. Okay, why don't you go ahead and try to factor that last part